So this is a setup similar to what you had. Well, like last week you worked with a cantilever beam to determine the natural frequencies. So when you have the natural frequencies, you can, well, it's important to know because if you drive the system at that frequency, it's going to respond. Yeah, so that's what we're going to demonstrate here. So the first natural frequency of this is around 4 hertz, and start off at 1 hertz, and then increase slowly. See it, the amplitude is actually like 4.5 hertz, but when you hit to that one spot, it increases a lot. But then when you go above it or below it, it settles down. So then continue going up. That's the other one. So continue going up. And then you hit the tip. Yeah. So the next one's at, I think around 25 and a half. And the other thing you can see is right there, there's a nodal point where there's no amplitude. So if you were doing a test on a machine part and you wanted to put a strain gauge on and determine, what was happening at resonance, if you put the strain gauge at a nodal point, you're not going to measure anything. So it's important to watch out for those if you were ever, going to set up an experiment or anything. So that's one mode of vibration. Another one, go up. You see how it gets very smooth, and then it'll hit another natural frequency and start vibrating a lot again. Alright, so there's another one, about 85 and a half. And here there's 2 nodal points, there's one there, one there. So it's a different mode of vibration. And again, the same thing, it'll smooth out when you go above and below that. So when they're tuning or making the parameters for different rotating machinery, they often determine where the natural frequencies are, and then that way they know not to run it at that speed. So for example, with a jet engine, the turbine blades, they'll have their own natural frequency from the rotations and also from the aerodynamic loads. So they want to avoid running at the engine RPMs that are going to cause resonance. So they'll know not to set it, say like 1500 RPM or something, if that's a resonant frequency. Otherwise the engine will basically self-destruct, and that wouldn't be good. So yeah, that's the main point of this demonstration, to show how you get different nodal points on the beam, and also just how the natural frequency can cause a dramatic change in amplitude of the vibration. For today's lab, it's basically the same as we did last week, except you don't have to do the theoretical calculation part of it.